So special thanks to the guys from the RMIT Formula SA teams, the combustion and the electric vehicles, obviously you can see here on the stage. There's 4 or 5 guys here today who'll hang out in the breaks if people do have questions. And certainly if you're from a company you're interested in sponsoring the teams and working with the students, please have a chat to the guys during the break. And coincidentally, Michael actually comes from RMIT. He's an alumni. He was the team leader in 2014 on the electric car. So he's also a great person to talk to about Formula SAE and perhaps how his experiences at university helped him get the job at ANCA and move his career on into an area where he's obviously passionate, and he'll be talking about today. So thank you, Michael.
Yeah, so I actually helped run the team a couple of years ago, and you can see that ANCA is also one of the main sponsors of the electric team here, so happy to talk about that as well in the break. I promised them I'd go through ANCA as quickly as possible, so there's already some missing things from this slide. But ANCA are a Melbourne-based company that design and build 5-axis CNC tool and cutter grinders. That's the one. So our 3 divisions are responsible for the CNC, the structure of the design is ANCA CNC machines. We have a subsidiary, ANCA Motion, who are responsible for our drives and motors, which are all designed in-house, and also a company, Tinfish, based in Thailand, that do all of our canopies and sheet metal. We develop this CNC tool and cutter grinders that produce some of the highest precision tools in the world, responsible for a lot of industries, from aerospace through to consumer electronics. Pretty much if you have an iPhone or a Galaxy, an ANCA product has probably touched your phone. So just briefly, I'm not going to stick too much on our products, just get to ANSYS as quickly as possible. We have a range of 5-axis machines for a range of industries, large, small, things from fake hips to sub-micron accurate tools. This is basically our product range. Also doing our drives, CNCs, motors is our motion division, and all the sheet metal done in Thailand. A lot of 4-wheel drive undercarriage stuff and aftermarket things as well. And we're based all around the world, so we have about 600 employees here in Melbourne and another 300 or 400 around the world. Almost all of our engineering is done out in Bayswater here. It's our vision to be as innovative as possible in driving the new technology in this market, so that's where ANSYS really comes into its stride, and we're new to ANSYS at ANCA, really introduced about 3 years ago, but we're starting to move into simulation is becoming a more and more important part of what we do across every division. I'm just going to go through a couple of examples of some of the products that we're using and how we're using them here at ANCA. ANSYS Mechanical is probably the main product we use at the moment in our mechanical engineering division. So it's mostly sticking to the static structural, but more and more moving into our modal analysis, harmonic response, rigid dynamics, and topology optimization, especially since ANSYS 18. It's really coming into the forefront of our preliminary design. So before we get to launching products, we're really starting to use it as early as possible in our design phase, and things will come to examples about how we see Discovery Live and other products coming in as early as possible into the process. This is one example we've been working on recently. We have quite complex non-linear problems at ANCA. One of this example here is a collet example, holding a custom tool from one of our clients in Germany, and trying to understand how the surface contact of a collet changes with minute changes in the tolerance of the part. So we work in the sort of micron to 10 to 1 micron range, and so the tolerance of this part being plus or minus 10 microns in any direction has a significant impact on this surface contact and the ability of us to hold a tiny part. So we've been using ANSYS to understand that interaction and understand how much clamping force is needed in order to deal with those sort of changes in the micron level. Something that I personally have had a lot to do with is the use of modal and harmonic response. Our 5-axis CNC machines are extremely complicated when it comes to a modal analysis in a 5-axis. As the axes move around in 5 axes, that changes our modal response and our harmonic response significantly, and the way that interacts with our servo tuning is extremely complicated. So we've been doing a lot of work to try to understand, as we make component-based changes in a modal space, how that drives key areas of our harmonic response, and that allows us to understand how our control and motor tuning is going to be affected to try gain greater performance for our customers, increasing like servo performance, servo bandwidth, and able to respond to more sub-micron level changes. Topology optimization, especially in the last release, has started being used by a couple of our engineers. We have very heavy, very complicated saddles on our axis that need to maintain stiffness to often micron level across our rails and things like that. So we're using topology optimization to try and make them as lightweight but without losing any rigidity. Still in the early stages of using this, but we see this as really important as we get more and more involved in trying to optimize our machines. Customers always want to push our performance to new levels every year, and in order to do that, we need to make sure that we're never compromising on our stiffness, but we continue to drive greater performance, lighter components, etc. And ANSYS Discovery. So since the launch last year, we've started trialing the use of ANSYS Discovery. We see this as a really great way to put this sort of tools and really forefront optimization and trial discovery into the hands of as many engineers as possible, particularly our mechanical engineers when they're first concepting parts, before we get into validating that and even just doing the more accurate stuff back in ANSYS Mechanical, trying to play around with how we just get that visual understanding of, as we change gussets and bracketry and things, how are we maintaining that level of stiffness across the board. And going forward, we see ANSYS as a pretty important part of maintaining that competitive edge. We've been working with LEAP to start talking about the use of ANSYS in some of our electrical design and trying to, we have quite good simulation tools for our control systems, and we're trying to start to integrate those control packages with ANSYS, particularly around the sort of modal harmonic space, and trying to understand how we can optimize performance using the complete ANSYS package. Some of the things Luke's just talked about, I'm sure are going to make my life a lot easier, so I'm looking forward to getting some of them. And as we grow, the use of our remote solver manager for some of our large packages is very important. So we're trialing that at the moment, but again, we've only had the ANSYS package at ANCA for 3 years, but we're already seeing it really integrate into all engineering departments, and we're trying to grow from there. Just some contact details about us. I'll hang around for the break, but if you've got any questions about us or the car that I used to be a part of, feel free to have a chat.